The National Electrical Code (NEC) does not specifically prohibit running a lower amp welding machine from a higher amp receptacle. However, there are some factors to consider. A 60 amp circuit is capable of supplying up to 60 amps of power. A 30 amp welding machine will draw up to 30 amps of power. Therefore, it is possible to safely operate a 30 amp welding machine from a 60 amp circuit and receptacle. The circuit breaker or fuse associated with the receptacle provides overcurrent protection. In this case, the 60 amp breaker will trip if the circuit draws more than 60 amps. Since the 30 amp welding machine will not draw more than 30 amps, it will not trip the breaker. The receptacle must be rated for the amperage of the welding machine. In this case, the receptacle is rated for 60 amps, which is higher than the 30 amps required by the welding machine. Therefore, the receptacle is suitable for use with the welding machine. Based on the NEC code, it is not prohibited to run a 30 amp welding machine from a 60 amp receptacle. However, it is important to ensure firstly the circuit and receptacle provide sufficient amperage and overcurrent protection, and secondly, the receptacle is rated for the amperage of the welding machine. While there is no specific NEC code prohibiting this practice, the following sections may be relevant. Firstly, NEC section 430.22. A. Overcurrent protection, and secondly, NEC section 430.30. B. Receptacles and other outlets. Overcurrent protection is a critical aspect of electrical safety, especially when dealing with welding machines. Understanding how it works and how it relates to the NEC is essential for safe operation. Overcurrent occurs when a circuit draws more current than it is designed to handle. This can be caused by a short circuit, an overload, or a ground fault. If the overcurrent is not interrupted, it can cause damage to the equipment, start a fire, or even cause an electric shock. Overcurrent protection devices are designed to interrupt the flow of current in the event of an overcurrent. The two most common types of overcurrent protection devices are circuit breakers and fuses. Circuit breakers are electromechanical devices that trip and open the circuit when an overcurrent is detected. Fuses are one-time use devices that melt and open the circuit when an overcurrent is detected. The NEC requires that all electrical circuits be protected by overcurrent protection devices. The size of the overcurrent protection device must be matched to the ampacity of the circuit. The ampacity of a circuit is the maximum amount of current that the circuit can safely carry. The NEC provides tables that list the ampacities of different types of conductors. When selecting an overcurrent protection device, it is important to choose one that is rated for the ampacity of the circuit. If the overcurrent protection device is too small, it will trip or blow prematurely. If the overcurrent protection device is too large, it will not protect the circuit from overcurrent. In the context of welding machines, NEC section 430.22 addresses the overcurrent protection requirements for motor branch circuits. Welding machines often incorporate motors for various functions such as wire feeding or cooling. This section of the NEC mandates that the overcurrent protection device for a motor branch circuit must be capable of carrying the starting current of the motor. Motors draw a significantly higher current when they start up compared to their normal running current. If the overcurrent protection device is not sized appropriately, it may trip during motor startup, causing nuisance tripping. To address this, the NEC allows for the use of overcurrent protection devices with higher ratings to accommodate the motor starting current. However, the overcurrent protection device must still provide adequate protection against overcurrents caused by short circuits or ground faults. The specific requirements for overcurrent protection device sizing are detailed in NEC section 430.52. This section provides tables and formulas for determining the maximum allowable size of the overcurrent protection device based on the type of motor, its horsepower rating, and its full load current. Receptacles and other outlets are another important aspect of electrical safety, especially when dealing with welding machines. NEC section 430.30. B addresses the requirements for receptacles and other outlets used with welding machines. This section of the NEC mandates that receptacles used with welding machines must be of the grounding type and must be rated for the voltage and current of the welding machine. Grounding type receptacles provide a path for fault current to flow back to the source, which helps to protect against electric shock. The receptacle must be rated for the voltage and current of the welding machine to ensure that it can safely handle the load. The NEC also requires that receptacles used with welding machines be located in accessible locations and be protected from physical damage. Accessible locations allow for easy connection and disconnection of the welding machine. Protection from physical damage helps to prevent damage to the receptacle, which could create a safety hazard. In addition to the requirements for receptacles, NEC Section 430.30 B also addresses the requirements for other outlets used with welding machines. Other outlets may include disconnect switches or terminal blocks. These outlets must also be rated for the voltage and current of the welding machine and must be located in accessible locations and be protected from physical damage. When installing receptacles or other outlets for welding machines, it is important to follow all of the requirements of the NEC. This will help to ensure that the installation is safe and that the welding machine will operate properly. The NEC is a comprehensive set of standards that covers all aspects of electrical safety. It is important for anyone working with electricity to be familiar with the NEC and to follow its requirements. By following the NEC, you can help to prevent electrical accidents and injuries. In summary, while the NEC does not explicitly forbid using a lower amp welding machine with a higher amp receptacle, several factors must be considered to ensure safe operation. Firstly, the circuit's overcurrent protection, typically a circuit breaker or fuse, must be appropriately sized to protect the wiring and equipment from overloads and short circuits. Secondly, the receptacle must be rated for the maximum current that the welding machine is expected to draw. Finally, it is always best practice to consult the NEC and other relevant standards to ensure compliance and safety. In addition to the NEC sections mentioned, other sections may also be relevant depending on the specific installation. For example, NEC Section 110.3 addresses the requirements for equipment examination, identification, installation, and use. This section requires that all electrical equipment be installed and used in accordance with its listing and labeling. The listing and labeling of electrical equipment provide important information about the equipment's voltage, current, and other ratings. It is important to follow the manufacturer's instructions when installing and using electrical equipment. NEC Section 250 addresses the requirements for grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. Bonding connects all of the metal parts of an electrical system together, which helps to prevent voltage differences from developing between them. NEC Section 300 addresses the requirements for wiring methods. Wiring methods include the types of conductors, cables, and raceways that are used to install electrical wiring. The NEC specifies the allowable wiring methods for different applications. It is important to use the correct wiring method for the application to ensure that the installation is safe and that the wiring will last for many years. NEC Section 400 addresses the requirements for flexible cords and cables. Flexible cords and cables are used to connect portable equipment to electrical outlets. The NEC specifies the allowable uses for flexible cords and cables. It is important to use the correct type of flexible cord or cable for the application to ensure that it is safe and that it will last for many years. When working with electricity, it is always important to follow safe work practices. Some basic safe work practices include: firstly, always de-energize the circuit before working on it. Secondly, use insulated tools. Thirdly, wear appropriate personal protective equipment. And fourthly, never work alone. By following these safe work practices, you can help to prevent electrical accidents and injuries. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work. Welding machines present unique electrical demands due to their high current requirements and intermittent operation. Understanding the specific electrical codes and safety practices is crucial for preventing hazards and ensuring a safe working environment. In addition to the NEC, other standards and regulations may apply to welding machine installations, such as those from the Occupational Safety and Health Administration (OSHA). OSHA sets workplace safety standards that employers must follow to protect their employees from hazards. These standards may include requirements for electrical safety, personal protective equipment, and ventilation. It is important to be aware of all applicable standards and regulations and to follow them carefully. The proper selection and installation of welding machine receptacles are critical for safety. The receptacle must be rated for the voltage and current of the welding machine, and it must be properly grounded. The receptacle should also be located in a convenient and accessible location away from flammable materials. Extension cords should be used sparingly and should be of the appropriate size and type for the welding machine. Overloaded or damaged extension cords can create a fire hazard. Regular inspection and maintenance of welding machines and their electrical connections are essential for preventing problems. Check for loose connections, damaged insulation, and other signs of wear or damage. Repair or replace any damaged components immediately. Proper ventilation is also important when welding. Welding fumes can be harmful to your health, so it is important to work in a well-ventilated area or to use a fume extractor. Always wear appropriate personal protective equipment, including a welding helmet, gloves, and protective clothing. These items will help to protect you from burns, sparks, and other hazards. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install or repair your welding machine. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from harm. Here's a more detailed breakdown of some key considerations. Firstly, understanding the welding machine's electrical requirements. Welding machines typically have a nameplate that specifies their voltage, amperage, and duty cycle. The voltage indicates the electrical potential required to operate the machine, while the amperage represents the current drawn during welding. The duty cycle indicates the percentage of time that the machine can operate at its rated current within a specific time period, usually 10 minutes. It is crucial to ensure that the power source and receptacle are compatible with the welding machine's voltage and amperage requirements. Secondly, selecting the appropriate receptacle and plug. Welding machines typically require specialized receptacles and plugs that are rated for higher currents than standard household outlets. These receptacles and plugs are designed to provide a secure and reliable connection that can withstand the demands of welding. The National Electrical Manufacturers Association (NEMA) publishes standards for receptacles and plugs, which specify their dimensions, voltage ratings, and amperage ratings. It is important to select a receptacle and plug that are compatible with the welding machine's electrical requirements and that meet NEMA standards. Thirdly, ensuring proper grounding. Grounding is an essential safety measure that provides a path for fault current to flow back to the source in the event of an electrical fault. This helps to protect against electric shock and fire hazards. Welding machines must be properly grounded to ensure that the metal parts of the machine are at the same electrical potential as the earth. This can be achieved by connecting the machine's grounding conductor to a grounding electrode, such as a ground rod or a metal water pipe. Fourthly, using the correct size and type of conductors. The conductors that supply power to the welding machine must be of the correct size and type to carry the required current without overheating. The NEC specifies the allowable ampacities of different types of conductors based on their size, insulation, and installation method. It is important to select conductors that are rated for the maximum current that the welding machine is expected to draw and that are installed in accordance with the NEC. Fifthly, providing overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to the wiring and equipment. Welding machine circuits must be protected by overcurrent protection devices that are sized appropriately for the welding machine's electrical requirements. The NEC provides guidelines for sizing overcurrent protection devices, based on the type of welding machine, its voltage, and its amperage. Sixthly, following safe work practices. Even with proper electrical installations, it is important to follow safe work practices when operating welding machines. These practices include, firstly, wearing appropriate personal protective equipment, such as a welding helmet, gloves, and protective clothing. Secondly, working in a well-ventilated area to avoid inhaling welding fumes. Thirdly, keeping flammable materials away from the welding area. And fourthly, never working on electrical equipment while it is energized. Seventhly, consulting with a qualified electrician. If you are not comfortable working with electricity, it is best to consult with a qualified electrician to install or repair your welding machine. Electricians have the knowledge and experience to ensure that the installation is safe and that it meets all applicable codes and standards. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from harm. Always prioritize safety and consult with qualified professionals when needed. The NEC is regularly updated to reflect changes in technology and best practices. It's crucial to stay informed about the latest revisions and interpretations to ensure compliance and safety. The NEC is not intended to be a design manual, but rather a set of minimum requirements for electrical safety. It is the responsibility of the designer and installer to ensure that the electrical system is adequate for its intended purpose. The NEC is a living document, and it is constantly being revised and updated. It is important to stay informed about the latest changes to the NEC to ensure that your electrical work is in compliance. Many jurisdictions require electrical work to be inspected by a qualified electrical inspector. The inspector will verify that the work is in compliance with the NEC and other applicable codes and standards. It is important to cooperate with the electrical inspector and to address any issues that they identify. Electrical safety is a shared responsibility. Everyone who works with electricity has the responsibility to follow safe work practices and to comply with applicable codes and standards. By working together, we can create a safer environment for everyone. Welding processes can introduce unique electrical hazards, such as stray currents and ground loops. These hazards can be minimized by following proper grounding and bonding techniques. Stray currents can occur when welding current flows through unintended paths, such as metal structures or equipment. These currents can cause overheating, damage to equipment, and electric shock. Ground loops can occur when there are multiple ground paths in an electrical system. These loops can create circulating currents that can interfere with the operation of equipment and cause electrical noise. To minimize these hazards, it is important to ensure that all metal structures and equipment are properly bonded together and connected to a common grounding point. This will help to provide a low impedance path for fault current to flow back to the source. In addition to grounding and bonding, other safety measures can be taken to minimize electrical hazards in welding operations. These measures include, firstly, using insulated welding cables and electrode holders, secondly, keeping welding cables and equipment dry, thirdly, inspecting welding cables and equipment regularly for damage, and fourthly, never welding in wet or damp conditions. Always follow the manufacturer's instructions for the safe operation of welding machines.